Have you ever wondered if there's a hidden code that governs how elements behave? What if I tell you that the periodic table isn't just a list of random elements, but a carefully crafted map that reveals pattern in how these elements react? Imagine being able to predict how an element will react or even how big it is just by looking at where it sits on the periodic table. In today's lesson, I'm going to show you the magic behind periodic trends, how everything from atomic size to electronegativity follows a predictable pattern across the table. Are you ready to master this hidden knowledge? Let's get right into it. Periodic laws are the rules that describe how elements behave as we move across or down the periodic table. This trend includes atomic radius, ionization energy, electronegativity, and electron affinity. Each of these properties changes in a predictable way depending on the element's position on the table. Let's start with atomic radius, or simply put, how big an atom is. As you move from left to right across a period, atoms get smaller. Why? Well, the protons in the nucleus are pulling electrons in closer, making the atom more compact. But as you move down a group, atoms get bigger because each new period adds a layer of electrons, increasing the distance from the nucleus. For instance, lithium. Lithium has a much larger atomic radius than fluorine, even though they are in the same period. And if you compare sodium to potassium, you notice that potassium is much bigger because it's one period lower. Let's test your understanding. Which do you think is bigger, magnesium or calcium? Remember the trend down a group. Drop your answer in the comment section.